For sure. Yep. Let's get started. Yeah, thanks everyone for this opportunity to present the work we did at Coinbase using SPIFFE and SPIRE. My name is Zhengneng, along with my colleague Michael Cieplak.
Everyone.
Yep. And Michael, you want to introduce yourself a little bit?
Yeah, I'm Michael. Yeah, I've just been working on the routing team here where we own SPIFFE and SPIRE. So yeah, nice to meet everyone. Excited to be talking with everyone here.
Yeah. Cool. So we can get started to talk about the work we did. Awesome. Yeah, so today's agenda will be broken down to three different topics: background, where we're coming from; architecture, how did we tackle this problem; our journey, how did we get through all of this. So for the background, who are we? As you know, Coinbase is the most compliant and trusted cryptocurrency exchange. We're responsible for buying, selling, transferring, and storing crypto for our users. So you can tell there are a lot of assets on our platform, so security is always our top priority. And as who are we? As a team, info routing. We are responsible for edge routing, service identity, and service mesh. So what are our top security requirements? Zero trust network. Given the whole company is running in the public cloud, we want to make sure each service RPC call is properly authenticated. No workload attestation. We won't provision any identity unless every workload out there is properly attested. Leverage industry standards and open source. We don't want to reinvent the wheel here. Leveraging a mature industry solution, which has been proven in production, can help us focus on our mission. No bound private keys. Private keys do not leave any node. We don't want the private keys to leave the node for any reason. Short-lived identities. We want to make sure identities are constantly being rotated to reduce the amount of time they could be compromised. Environment isolation. Make sure all the communication between environments are not allowed. For example, dev, staging, production, they are not supposed to talk to each other. Touchless key management, automated key management with no human access. We don't want to see any users in the company have access to any to the private key material. Everything is rotated, issued by the system itself. And then why we choose SPIFFE and SPIRE? SPIFFE is an industry standard that is used across a variety of open source projects. This makes the integration seamless. SPIRE also is a CNCF graduate project, like Keegan just mentioned, which has been utilized by a large amount of companies in production. Short-lived identities. SPIRE has the built-in capability to handle the rotation of all the identities, so that we don't have to build any bespoke logic ourselves. MTLS, we love this feature. We want to migrate to using MTLS everywhere instead of JWT, as our legacy identity provider was JWT based, and we want to move away from that. Abandoned plugins. Wow, this feature. No workload attestation. EC2 Kubernetes plugin. SPIRE provides a variety of different plugin types for different kinds of compute cloud providers, which enable us to do proper attestation of workloads. This is important for us because we are in the progress of doing a migration from EC2 to Kubernetes. And we want the identities to be compatible with each other so that services across the compute providers can be able to seamlessly communicate with each other. And the SPIFFE standard makes this possible. Cloud providers CA plugins. There are different plugin types to integrate with cloud provider CAs, such as AWS private CAs, GCP Certificate Authority Service CAS. And as for the architecture, over to you, Michael.
Cool. Thank you so much, Zhengneng. So yeah, now let's talk a little bit about like our architecture and what are the use cases where we're utilizing SPIFFE and SPIRE for. So first of all, our primary feature is service authentication, right? So whenever two services are communicating with each other, we want to make sure that they're properly authenticated. Then once we have that authentication layer, then we can do the proper authorization level on top. Additionally, like Zhengneng was mentioning, we want to provision identities for different workload types, initially for EC2 Kubernetes, so that they can seamlessly communicate with each other through the SPIFFE standard. And finally, our ultimate goal is to move into the service mesh. So we want to actually utilize MTLS there everywhere in Istio. So that is our eventual goal. So now let's talk a little bit about like our Spire nested architecture and our CA chain design as well. So at the very top, we have a root CA. We have different ones based on different environment types, such as production, development, staging, etc. And this one is actually fully offline. Then we have an intermediate CA, which is actually uploaded to the cloud provider CA system. So this one is actually considered online. Then down here, we have something called a root Spire server, which gets its own CA from the intermediate. And at the very bottom, we have something we call the main Spire server. So this is our nested architecture where we have the root and the main multiple levels of Spire server here. Then the end entities themselves, which are actually getting the workload identities and running the Spire agents, are communicating with the main Spire server. So what are some of the benefits of this approach? Like, why did we go along with it? Well, first of all, we have minimal storage in the cloud provider. So we only store the intermediate CA, no other certificates. So this heavily reduces the cost. Also, we're a little bit more resilient, for example, to cloud provider CA outages. If there's any like blip in uptime for the intermediate, our root Spire server is actually, its own CA is valid for multiple days so that it can keep running and essentially issuing CAs for the main Spire servers. And finally, the main advantage and benefit of why we chose this architecture is that we can shard out the Spire main much more easy. So as you can see here, most of the traffic that is occurring is actually between the Spire agent and the main Spire server. So we can actually shard out the main Spire server, whether that is to different cloud provider accounts or particular Kubernetes clusters, so that wherever the load is occurring, we can basically put up a shard there and horizontally scale that out. And then still have them all go essentially to the same root server so that they're all part of the same chain and can seamlessly authenticate with each other. So now let's take a look at our federation setup and our trust domain design. So this is just one example. Typically, our trust domains are basically three components. One is the environment, such as production, region, and the cloud provider. So let's say, Prod West in this case. Here, we basically have our CA chain that we were discussing, and also the root and main Spire nested architecture as well. And just to show another example, this is like East running essentially the same stack. So how exactly do we get two of these to communicate with each other across the trust domain? So what we do is we basically federate across these trust domains, essentially regions. So the main Spire servers will be doing the federation here so that they can exchange like the CAs and also the public JWT keys as well. So that whenever, workload from this particular trust domain is making a request to the other, it will have the access to the public JWT keys of the other trust domain so that it can properly authenticate the call. So what are some of the benefits of this approach, or why did we actually choose it? So first, we have region separation. So it's very important for us that we actually have separate identities per those trust domains as essentially per region. The reason for this is we want to have proper separation due to compliance reasons and also for authorization as well. And finally, like the federation setup is really nice because you can actually control which services are federated and can talk across the trust domains. So by default, like the cross trust domain communication is actually not allowed, and we only onboard specific services. So like the Spire server makes this very easy, as you can actually register on each particular workload which one should be federated and which one can actually accept the cross-region traffic as well. So now let's talk a little bit about like our journey and how we went about integrating SPIFFE and SPIRE into Coinbase. So first, we engaged with various teams from day one. So, when we were designing our architecture and going through all the attestation flows that we want to support, we engaged very heavily with our cloud team, basically our security teams, networking teams, to really make sure that the architecture that we chose fits into the model of how we provision our cloud provider accounts and also our Kubernetes clusters. Also, the CA chain is something that we heavily collaborated closely with security on Kenneth that introduced himself here, for example. So they were actually responsible for, designing the entire PKI layer, the root and intermediate Cs that you saw. And also they were responsible for doing the root ceremony process so that we could actually have those CAs available for us to use. And we did a variety of different POCs, right? So we tried different architecture styles related to like nested setups, federation at different levels. And we really tried out a lot of different setups just to get the pros and cons for each before we actually settled on the one that we showed here. And finally, what's really important is the migration for us, right? Like if we have thousands, if not tens of thousands of microservices, how do we actually migrate from the legacy provider to SPIFFE and SPIRE? So first, what we're going to do to basically allow for an easier transition is we're going to utilize JWT because our legacy provider is JWT based. So services already used to doing that service authentication at that L7 layer. So what we're going to do is we're going to replace SPIFFE, basically our legacy JWT with the SPIFFE and SPIRE one. And this also gives a performance benefit because the signature algorithm here is a little bit better as well. And what we really wanted to focus on is like having a hands-off migration for service owners. So, since we have so many microservices, it would take very long for us to actually do the migration if they manually had to do them all themselves. So what we've done is we've updated basically like all our libraries, created a control plane so that we're able to dynamically actually switch JWTs for services so that our team can handle most of the migration actually. So what we can do is basically dynamically flip from legacy JWT to SPIFFE and then do the migration of our entire stack that way. And ultimately, we want to move to Istio. So basically, we're integrating SPIFFE and SPIRE with Istio from day one for MTLS everywhere. And we really want to make sure that we're utilizing it for both data and control plane as well. So now I'll hand it back over to Zhengneng to talk a little bit about our operational experiences as well.
For sure. Thank you, Michael. So for the operational experiences, I will share two examples we experienced. First, during our server upgrade from 1.5 to 1.6, we realized the deployment took longer than expected. We looked into it and found out it's happening while connecting to the database. With that, we came back to the change to log to understand what the changes were. It's actually trying to clean up the no resolver map entries during bootstrap. This takes a long time because we have millions of stale SPIRE agent entries. The approach we took was, first, extend the health check time for the server coming up. Secondly, extend the deployment timeout. With these two steps, it can help us make sure the cleanup finished in time. Third, for the next step, push the stale SPIRE agent entries offline and bring the number down from millions to thousands. And then for the first rollout attempt, we want to let the no resolver map entries cleanup happen during bootstrap. Last but not least, redeploy to confirm next deployment time is dramatically reduced. In fact, we observed 90% deployment time reduction after cleanup. And in the second example, I would like to share what we observed during the 1.6 to 1.7 SPIRE agent upgrade. We observed the agent memory usage spikes across all the EKS clusters. The first thing we did was to enable PPOP for the investigation, which is exposed by the config SPIRE provided. Besides that, we also enabled continuous profiling, given spikes came in unpredictable. We also collaborate with the community to look for further insight and action items. For now, we are trying to optimize memory usage for FastJSON, as we found out FastJSON was allocating a large amount of memory. So we make a patch on the FastJSON library and are doing ongoing GC tuning. With all this, SPIRE agent is becoming more performant. Back to you, Michael, to talk about the contributions.
Cool. Yeah, so just want to talk a little bit about some of the contributions that we basically made. So yeah, we did some small bug fixes related to like no panic in Aussie middleware, some documentation fixes as well. But primarily what we're doing is we're focusing on the Istio integration. So one of the things that we actually brought up, I think Troy mentioned this in our comments here as well, is that basically we want to allow SPIRE to issue wildcard certificates. So someone actually implemented this already from the community, so thank you very much. But essentially the use case for us is, while we're migrating into the service mesh, we have a lot of like services that are outside of the mesh. So we need a way for them to communicate with services inside the mesh. So what we want to do is run Istio Ingress basically with a wildcard certificate issued by SPIFFE and SPIRE so that it can terminate the TLS for those legacy services. And otherwise, yeah, basically, we would have to manage a lot of different certificates since we have a lot of different domain names and our SAMs would get pretty crazy. So this is just one example. The other example is we're trying to collaborate with the Istio maintainers to improve SPIRE integration for the control plane CA. So basically, like we want to make sure that we're utilizing SPIFFE and SPIRE everywhere in Istio, not just the data plane, but for the control plane. So what we really want to make sure is that, like, all the Envoy sidecars when they're communicating with Istio D, that all of that communication is based off the SPIFFE and SPIRE CAs and certificates that we are issuing. So we're going back and forth to see how we can basically improve this process of utilizing SPIFFE and SPIRE there and make it more dynamic to leverage the certs here. Additionally, we also had an AWS Reinforced talk with Kenneth that is also here. And here we talked a little bit more into our PKI based on basically the PKI design and also some of the non-SPIFFE and SPIRE use cases outside of service authentication as well. So just sharing that if you're interested. And
did I do something? I started typing and everything disappeared.
Yeah,
I think he just lost connection. Give him a minute. He might connect back.
yeah.
can you hear? Is it back?
Yeah, you're back.
Okay, yeah, I don't know. The Zoom just crashed. I basically got it crashed in the Zoom. We're using the browser version instead of downloading the client, so that may be why. Okay, can you see this?
Yes.
Okay, thank you so much. Sorry about that. Yeah, so final point, just want to mention, yeah, like we're very happy to collaborate further with the community. And definitely are looking forward to meeting everyone here and yeah, further collaboration in the future as well. So just want to say, yeah, thank you so much and open it up for Q&A. I saw there was a couple questions as well in the chat. If you don't mind repeating them because my Zoom crashed, so I don't see them.
Yeah, no worries. I'll take up the question, but thank you so much. I think there are a lot of questions. And I'm going to just pick a few out. What are the main motives for aiming for X509 versus JOT as the end goal?
Sorry, one more time. Like,
what was the motives for using X509 versus JOT?
I see. Yeah. So basically, like, we want to integrate to MTLS everywhere. So the idea is that, that's happening at a layer below, right? Like L3, L4, it's much faster to basically utilize certificates as opposed to doing JWT at L7 layer and then verifying the signature every time. Also, when you have long-lived connections, you do that validation once during the initial connection attempt. So overall, it's mostly a performance thing. And additionally, we want MTLS, so we want both client and server side to verify each other as well. So that's very important for us.
Perfect, thank you. And what are your biggest pushback you experienced while working with partner teams? How did you solve it?
Yeah, so I don't know. I think the primary thing is like, if services need to manually onboard and then switch JWT and then roll out and migrate traffic X percentage at a time, that requires us like going out to those teams and basically saying like, hey, can you put this on your roadmap in the next quarter or something, right? Which is, you get some pushback and stuff there. So I think that's where we like really heavily focused on like, let's implement a control plane. Let's have dynamic features so that we can actually flip JWT for you. So now it's more of a matter of like, we'll go to the service teams and be like, we're gonna flip it here, and then we kind of go ahead and do it. And then we talk about the performance improvement as well, right? Like you're saving, in what we've seen from our legacy JW provider, like 10x the latency and the verification flow. So usually they're very happy about that as well. Yeah.
Nice. Another one, how many federations are you currently doing? Is federation configuration painful in some way or any way?
Yeah, so I think the highest one that we have is like 4-ish right now, which is like basically like, if you had a graph or like nodes, you had 4 nodes and they're all federating with each other. So in the beginning, we did have issues. So basically like when we would deploy a Spire server, basically what happens is since all of these public JWT keys and CAs are in memory, what would happen is they would get rotated and the federation refresh would actually be very slow by default. So when we would see a deploy and then we saw services actually getting a JWT from the new servers that came up and had new public keys in memory, they would actually not be able to authenticate with basically other services running in another federation because they didn't have access to those public JWT keys yet. So what we had to do is we basically had to like, in our control plane, we're actually running refresh bundle very often. So we're actually like kind of spamming our Spire servers so that they're refreshing the bundles from a federation, I think every like 15 seconds or so. So that was one of the pain points that like initially what we observed when we were rolling that out. Yeah, so that's something like, we had to sit down and figure out what was the issue and stuff there.
Right. I know we have 5 more minutes for Q&A. So what was your stale entry cleanup process?
Yeah, Zhengneng, do you want to talk about this one?
Yeah, for sure. So we had a script to pull all those stale SPIRE agent entries, compare with like what we have done in life, and with that we are going to use our house-based CLI tool. Essentially, it's implemented using the SPIFFE the API. So we could use the delete API to delete all those stale SPIRE agent entries in our database. So that's how we clean them down. And so with the pushed SPIRE agent entries, so we can like make sure when the bootstrap happening, the cleanup process like running against the entries in our table is way less than what was before.
Oh, thank you. I think how long it took from we are looking and experimenting with it to we are running it in production?
Before we ran in production. So we had definitely had 1 quarter where we POC'd. So basically, like, 1 quarter where basically we were doing the POC, writing the technical design document, trying to get sign off from like security and a lot of other teams. I think that was a very long document and a lot of things to consider, edge cases and back and forth. And then I would say, I think it was like another quarter basically before we were actually had everything set up in production and then started to initially utilizing it. So somewhere around like, yeah, I think 2 to 3 quarters, I would say total to be running in production.
Oh, I think another one is more of a generic question, maybe for everybody. Anyone has anything to share on gradual SPIRE upgrade rollouts? I don't know if you guys want to take it or somebody else.
Yeah, Jaina, you want to talk a little bit about this? I know you've been
sorry,
in the process of basically any tips on like SPIRE server upgrade process and any pain points you've observed and stuff like that.
Sure. Yeah. So as the guidance is saying, like the +1 and -1 minor version difference between like agent and server. One of the quote unquote pain point is like we have to make sure our custom team, like our customer service team, needs to deploy and bring up the SPIRE agent version. So to make sure the delta in between would not be huge within threshold. And secondly, like we want to make sure agent like server upgrade, like the old agent still able to like do node and workload attestation, make sure they are seamless, and we observe like monitor the performance and monitor any errors coming up. So basically, that's how we make sure server upgrade is smooth. Also, for the federation, we want to make sure like any new or any remove federation, the control plane can sync all those federation entries seamlessly, and to make sure there's no hiccup like an upgrade process.
Yeah, and one thing that I like to add on there is I think like definitely like if you're doing something like EC2, for example, like, you know, typically depends on your deployer setup. Those are deployed through service owners. So what we found is definitely like, you know, in Kubernetes, it's easy because it's a daemon set. So we control it. We can roll it out on the cluster anytime we want. But EC2 is typically bundled with services, right? Like the SPIRE agent container. So I think one thing there is like trying to get the agents upgraded super early to allow like, you know, X amount of time for service owners to redeploy and pick that up. So I think that also takes a little bit of time.
Very cool. I know, Shiva, your questions.
Sorry, I was going to tie into that real quick. We kind of have the same process and checks and all that. For us, one of the main kind of things that trips us up, at least for what we do right now, is it's a kind of manual process to, okay, roll it out here. Is everything good? Okay, roll it out there. Is everything good? Sorry, that's all I had to say.
That's very accurate, yeah.
No, thank you, Keen. I think, Shivas, your both questions were answered. I think the upgrade and the stale entries. I think other people asked them too, but if not, feel free to unmute yourself and ask that question.
I think that did answer my question. Thank you.
Perfect.